Okay, so as promised, here is our institutional analysis and development to be applied to coupled infrastructure systems that we are discussing in this chapter. What we saw in chapter 2 was the framework for institutional analysis, and IAD is what we always talk about, institutional analysis and development. It's something that you have to get an intuitive sense for. So we talked about exogenous variables that determine eventually the outcomes and the evaluation criteria. So we had the biophysical conditions, which we discussed, and we'll apply this to a classroom and see quickly what we mean again in case you forgot. Attributes of the community that is involved in this institutional framework that we are applying to, and there are rules in use, of course, which then decide the various criteria for participants and who gets in, and defines the action situations. And there is of course a relation between the rules and the action situation, and that determines the interactions. And there are feedbacks always, because the action situation is not a stationary monolithic thing, that interactions often lead to new rules and new action situations, or modified action situations, and so on. Interactions determine the outcomes, and both interactions and the outcomes have evaluative criteria to make sure that the system is doing what it's supposed to do in the institutional analysis. So you can think of the institution being on track to do what it's designed to do, and that also feeds back to the exogenous variables in many ways. So quick example, of course, we applied to taking a course. Exogenous variables here, the biophysical conditions are determined by the university campus, attributes of the student population. Is it a big international crowd? Is it all male, all female? Is it mixed? What level of education are they there to seek? And of course there are university regulations about who gets in, what can you do once you get in, where you live, what can you do on campus, and so on. So then you have students, professors, teaching assistants, and so on, that determine our participants, and they, let's say, interact in the action situation of the course. Of course there are other action situations on campus, like sports or arts, performance, etc. So in this particular case we have lectures which feedback with the participants for various things like syllabi, modifying the syllabi, or making the exams, and so on, and that determine the grade. And there are evaluative criteria of the syllabus that is determined. So teachers get evaluated, students get evaluated for the grades, and that feeds back to the action situation and participants, and of course to the exogenous variables. So if you get a good grade and do well in your school, maybe you get rich and you pay back some money to the university or put your name on some building, and so on, right? So that brings us to looking at coupled infrastructure systems. In this section we present an extension of the IAD framework that includes some of the specific problems related to interacting infrastructures. So these are interacting infrastructure as well, human infrastructure, physical and intellectual infrastructures, and there is social infrastructure there as well, as to the living on campus and what it entails. So we'll do that here in a more robust way. The framework was developed by Anders, Janssen and Ostrom in the early 2000s to facilitate their study of irrigation systems. Janssen is one of the co-authors, and Ostrom was his postdoc advisor, based on whose work this whole book is written. The notion of infrastructures creating the action arena are implicit in the IAD framework. The details are not so explicit. The intent of Anders et al. Framework, the so-called robustness framework, was to make explicit how the different types of infrastructure discussed above come together to structure the action arena. To introduce, in this case irrigation, to introduce the framework We will focus first on a shared resource that is used by a number of resource users. This has been the canonical view for many of our small communities who interact with their resources. However, this raises the question of who creates the rules of how the shared resource will be used. So there are always rules associated with these systems, and we'll come to that in a minute in a bit more detail. In this framework, we explicitly include two levels of action arenas, namely the operational level and the collective choice level. So collective choice levels require really the set of rules that are agreed upon and enforced and modulated as required by the outcomes. The third component of the framework consists of the public infrastructure providers, who are the ones who create the rules for the resource users. My door just shut by itself. In small communities, all resource users might come together on a regular basis in the evening to discuss the challenges in governing their shared resource, so village level irrigation system or some such thing. There might be a chair, a treasurer, and some other roles within the group of public infrastructure providers, but they're all resource users and thus have a stake in creating rules to improve the performance of using the common resource. So information access and everything else is assumed to be equitable, so that decision makers or the treasurer's chair and other people in the governing body also are resource users, and yet they don't have a way of tilting the system to their own selfish interest. That's the basic assumption. So in the studies where the robustness of coupled infrastructure system framework has been used, a common finding is that the link between resource users, mainly human and social infrastructures, and public infrastructure providers, mainly human, social, and soft human-made infrastructures, so rules and regulations, is a critical one. So this robustness of the coupled infrastructure system framework, a common finding is that link between resource users, human and social infrastructure resource users, and public structure infrastructure. Let me read that again. I don't know why I'm fumbling this, sorry. In studies where the robustness of coupled infrastructure system framework has been used, a common finding is that the link between resource users and public infrastructure providers is a critical one. So when I read the material in the parenthesis, I tend to screw up the continuation of the sentence. The bigger the distance, the less the practical knowledge from resource users is included in creating institutional arrangements. So practical knowledge includes a particular type of human infrastructure that we mentioned before. A lack of practical knowledge may lead to policies that do not fit the reality that resource users experience, and therefore policies may not be effective. So if the practical knowledge is not inculcated in the policies, and they are not really, policies are disconnected from reality, then the policies may not be effective. On the other hand, local communities may not have the specialized knowledge, so a different type of human infrastructure may be needed to solve certain problems on their own, and therefore creating institutional arrangements where representatives of many localities are involved can be beneficial. So arrangements where representatives of many localities are involved can be beneficial. The fourth component of the framework is the public infrastructure, which includes mainly hard and soft human-made infrastructures. The public infrastructure providers may have decided on new institutional arrangements, but they may need a bureaucratic apparatus to implement and enforce those rules. So let's say the governing body made the rules, and then you need police, regulators, and so on, who actually enforce the rules. Tax collectors, property inspectors, and guards are all common essential human infrastructure to implement the social infrastructure of various types of coupled infrastructure systems. So canals, pipes, bridges, and satellites are part of the hard infrastructure of various types of coupled infrastructure systems. Okay, sounds complicated, but these are just because it's formal words that we have to use to define infrastructures, coupled infrastructures, and their interactions and action situations and the rules that determine the outcomes, right? So you put it together, this is how it looks. The coupled infrastructure system can be seen as a component of the institutional analysis and development framework. The resource system and the public infrastructure are directly related to the biophysical conditions that we talked about before. The resource users and the public infrastructure providers are directly related to the attributes of the community, and the public infrastructure is directly related to the rules in use. So let's add some details to the IID framework then. External context, biophysical conditions, attributes of the community, and the rules in use, which are going to go into the action arena as boundary conditions so that outcomes can be determined as planned or designed, and then feedback to modifying the conditions, attributes, and rules in use. In the action arena, we had a resource system, resource users which interact with each other, public infrastructure which facilitates resource users and also feeds back to the interaction between resource users and the resource system, and there is public infrastructure providers which interact with the resource users and provide financing and other things to public infrastructure. So together this action arena determines the outcomes, right? So this is kind of the analysis here. What is happening? The resource system and the public infrastructure are directly related to the biophysical conditions. The resource users and the public infrastructure providers are directly related to the attributes of the community. So resource users and the public infrastructure providers are directly related here, and the public infrastructure is directly related to the rules in use. Okay, so you get these multiple loops where feedbacks are happening. Inequality is an important component of the functioning of coupled infrastructure systems. We know from historical research and experimental studies that inequality may have negative consequences for the ability of groups and societies to solve collective action problems. So the attributes of the community often determine how the inequalities are dealt with, or whether the norms of the community attributes allow inequalities to be carefully taken care of, and protect the poor and the vulnerable and the so on, right? We know from historical research and experimental studies that inequality may have negative consequences for the ability of groups and societies to solve collective action problems. For example, where do we place the nuclear power station, or which economic sectors will have to reduce their water use to avoid major consequences of a drought? Whether it's a wastewater treatment plant, a coal power plant, or a nuclear power plant, there are a lot of details involved in how the groups decide these things, and how the inequalities can play into someone paying disproportionate price in terms of taking all the pollution, or living next to a dangerous facility like nuclear power station, or enjoying water when there is a drought beyond their fair share. If we have to reduce our carbon footprint, will the average Joe have to forego their holidays so carbon emissions from travel can be removed, while rich households can buy additional carbon emission rights? Okay, what happens if rich neighborhoods get off the grid by powering their houses with solar energy and driving around in Teslas? They are using the infrastructure and their wealth to create their own action situation to do things they want, then that can have a negative outcome in terms of equal access to roads, energy, and so on. Those who do not go off the grid will now have less capacity to maintain an already aging infrastructure. What if an elite group in society is better represented in the category of public infrastructure providers compared to lower income group. How will this affect the kind of policies that are developed? What types of public infrastructure are produced by this collective choice, i.e. the defense versus healthcare and education or environmental protection are the kind of collective choices, and then how the fairness of those infrastructures are perceived. So there is the idea of measuring fairness in some way, but how the poor perceive these things when they don't get health care, but the defense is spending a lot of money, or education is not equally accessible, but environmental protection is working so they can also benefit, and so on and so forth. So you can imagine many situations of coupled infrastructures where you have multiple participants involved. Could be a society, corporations, governments, and so on. Many rules are involved, but equity is a big challenge that has to be ensured as well. So let me leave this here, and we'll come back and read some stuff from these Andery's paper that we talked about in terms of analyzing the robustness of a coupled infrastructure. So there are some interesting ideas there to learn from. Okay.